Next up, very excited for our next speaker, who I only met a few days ago. My good friend Nikolai Spence, who's such a master weaver, introduced us, but I'll probably mispronounce his last name, but Ethan Baehrend has been involved in 3D printing technology for a few decades. He was pivotal in the development of hundreds of companies. He ended up doing the software for over a decade that led to what has become the kind of explosion of 3D printing companies. But since then, in the last 10 years, has been working, as he'll talk about, with kind of undercover about what he's about to share, which when we're talking about energy infrastructure in the built environment, a lot of us, when we think about impact, we're thinking about how we treat the earth, we're thinking about, energy systems, but so much energy, what does our energy go into? It goes into the building of things, the manufacturing of things. And that manufacturing, I can build a widget, and that has a certain impact. But beyond that, you have to get that widget to another place. There's so much in the supply chain that is a result of how manufacturing works today. And one of the things that I'm most excited about in this, so what we've done in Global Unity, we're kind of in stealth mode. If you're not part of Global Unity, maybe they haven't even heard of it. But we've put together some working groups on we put together different impact masterminds. One's on regenerative agriculture, impact measurement, reward, and incentive. And the one I think is probably most important that we've run so far is on creating a decentralized supply chain. That seems impossible outside of, locally grown food and maybe some, woodworking or simple product creation that can be done locally. But to actually be able to have something like that where you could have global product development or creation that doesn't depend on a global supply chain would be impossible until something like what we're about to hear were to come on board. So really appreciate Ethan being here and to have Creative Technologies be one of the organizations that's been in great support of Transformative Impact Summit. So let's welcome him warmly. Ethan, come on up.
Hi, y'all. So my name is Ethan Baehrend. I'm the founder and CEO of a company called Creative 3D Technologies outside of Austin, Texas. Basically, it's in the advanced manufacturing space, and since some of the company has been connected to non-competes. We've been gone for a little while since previous acquisitions or previous employments, but we've been making a lot of pretty crazy tech since then, and I'll go over that soon. But mainly want to focus on in this presentation is talking about a topic that's not really talked about at Ungun, even when I was speaking at the previous conference of parties out in Dubai, which is manufacturing supply chain and how that plays into a lot of greenhouse gases and energy consumption. And so basically want to talk about how it's a problem, raise some awareness for it, and then lead by example on what we're doing in it. So have a couple numbers here towards the back. Might be a little hard to read from other sections, but long story short, by far energy production is what is polluting the environment more than anything else. And there's no debate on that. But when I did a show of hands out in Dubai, 1 or 2 people raised their hand and I asked how many people you heard talking about manufacturing and how it relates to, sustainability and, global emissions, and only, again, 1 or 2 people raised their hand. And in my opinion, that's a problem because depending who's doing the studies, it is the 2nd or 3rd largest pollutant in the world. We shouldn't just be focusing on problem number 1. We should look equally at 2 and 3. And admittedly, there's to give a little bit of context on why it's so high, and actually it's been getting worse if we go to the next slide once the screen's back. But it's because of how we produce. Basically, if we go to a production line, you have a lot of large machines, and each machine, there we go. We have a lot of large machines, and each machine basically consumes its own power, generates its own waste, and as we demand more and more advanced products, you have to add more and more steps to that production line. The more steps you make, sure, you can put legislation on a lot of these factories that try to tell them to be more efficient, but you're not fixing the core problem. And the more steps we add, it gets rough. To give an example, if we go into jewelry manufacturing, a lot of jewelry manufacturing, when you're trying to use a precious metal like gold, you're losing over 30% of the gold as waste when you're trying to make jewelry. And if that's bad in the precious metal industry, think of how it is in a lot of other manufacturing. A lot of processes have 50 to 90% waste of what they use that you can't always reuse. And again, as we've demanded more advanced products, that's gotten worse. And a lot of transportation, over 60% of transportation, is also having to do with supply chain. And the majority of transport supply chain, when you play into that, it gets worse and worse, and worst of all, it's fragile. So to kind of summarize some of the key problems here, and I know it's a little hard to read with the light, so I'll instead say it. Basically, one of the cores is manufacturing itself. It's very colluded. Basically, if you want to make one type of part out of one set of materials, you go to one company that makes that one specific machine, and they'll sell it to you for one certain price point. You go to a little different price point, it's very infrequently directly competitive, where everyone's in their own little non-competitive niche and doing very well in it. So there's not much incentive to disrupt that, and that's why for over the past 3 to 5 decades, it's not changed. And as a result of that, we get into a second problem where there's limitations. We're starting to inspire a lot more products by nature. And if you cut a bone in different segments, it's differently hollow versus dense to be the lightest, strongest thing possible. It efficiently uses the materials that it has on hand to make the best thing for the function. And as we start to implement AI into design, as we implement a lot of new technologies into production, we start to hit the construction limitations. What I mean by that is when you go to engineering school, you're not taught what to make, you're taught how to make it. Here's a software that can make these shapes, and here's the machines on a production line that can make those shapes for you. And you're limited to that. And we need to be able to make that next generation of shapes and structures to enable the next generation of innovations, because right now there's a lot of hardware companies that can draw real benefit for the global populace that are failing because you just can't make the parts they need. And then third fold is, of course, supply chain I mentioned, and a lot of it kind of boils down to, I think, where we see a lot of, boils down to China in a lot of senses, where that is the majority of production. There's even been recent studies showing how a lot of the DoD's prime contractors are completely Chinese dependent. The only ways you're going to beat a superpower like that is either A, if you undercut their production costs, which is very hard to do. Again, they've been buying the same unchanging machines for the past 3 to 5 decades. Or B, if you somehow get a hold on them, get a foothold, get a corner on the next set of products and things that are going to define your next generation. And to give you a little visual on that supply chain side, try to really dumb it down. There's so many steps of added inventory. There's third parties you're buying from. There's retailers that have their own inventory that end up going to waste as our products keep evolving. We need to revolutionize both. And that's where it goes into the lead by example part, where Creative 3D Technologies, we're disrupting that large chain that we talked about. We're essentially giving people on-site, on-demand production and basically decentralizing the power from offshores and give it to the world. So what do I mean by that? Basically, clicker doesn't like me. We made something called single cell production. Basically, it's been seen as a concept in the manufacturing world for a long time, but it's a very private technology, and that's what we've been working on since, and that's what we get to finally talk about. Basically, on a production line, you go machine to machine. One's bending your metal, one's making your circuitry, one's molding your plastics, your carbon fibers, whatever. Single cell production's the idea of you make a machine, can move in all the right directions, use all the right chemicals, speeds, tolerance, torque, to do the jobs of any of the functions of the machines on the line. And instead of moving machine to machine, you move tool to tool and make a fully finished product onto one system, which you can't beat China cost for a single part, but the more steps it takes to make a final product, more competitive, if not cheaper, it gets. And that's where things get pretty interesting. And so we've actually done that. We have a system that we've kept private for a while called Diet. Basically is jumping between 20 different production methods at once, picking them up, dropping them in. So we've done things like drones, where you can see the little graphic there. We're 3D printing the plastic. We picked up and dropped in a semiconductor. We wired it, and we're even moving into semiconductor production. We're talking about a method that can make anything from biological components to different battery technologies to semiconductors, to building that all into a final product like drones, automotive, aerospace, and things even to maintenance. When we send supplies out to a lot of these third world countries, solar panels, water filters, things like that. You're not giving them the route to maintain it. And well, as a result, you're not properly serving the populace with supply chain. And so that's what we're looking to do by enabling people to produce on their own. But going to where we're at now, basically, if we were to give that to someone at the moment, it'd be a bit of a nightmare. Right now, everyone's used to, again, one machine makes one product. And so we're slowly taking pace for Amazon's book. Even though Amazon had the marketplace very early, you're not going to overnight just, here's your marketplace of everything. You're starting one market, blitz it, then slowly build into other subsectors. And so that's what we're doing, where we have technology called Evo, because 3D printing's very malleable in a lot of people's minds. It's still new. We're saying, introduce the word single cell solution of 3D printing. You'll do your $3.8 million tungsten titanium and Inconel, do your $2 million aluminum, your ceramics, your steels, your large parts, small parts, everything in one. But then slowly over coming quarters, we adapt little different modules that we show to let people go from, okay, here's printing to printing plus semiconductors, printing plus milling, painting, polishing. So then come 2027, people have a bit of a concept for it. So that's the one that we have out now, and it's in the hands of some great people like Disney, U.S. Army, automotive manufacturers, medical device producers, and folks of the sort. And at the moment, like I said, out in market, it's been actually well recognized. It's generating revenue. We have facilities producing it out of Austin, Texas. But to give the shameless plug sign, why we're trying to talk and raise a little more awareness is that, admittedly, we're over demanded. It's doing well and the unit's doing well, but we have demand for thousands right out the gate, and you don't really go from making something for over a decade to hundreds of thousands of unit production a month. You do a couple, you pass break even, and so we're scaling, looking for the right partners to help do so, and that's a slight ask. But to kind of give a bit of a conclusion, there's just not enough support for whether it's manufacturing or any other type of physical technologies. Most of the investment is going into the software. That's where a lot of people have made their capital. But if we talk about sustainability, impact, and emissions, where you're polluting isn't software. Where you're polluting is physical product, physical processes, and software can be a band-aid fix that can make some of those more efficient, but you're not fixing the crux of the problem. We need real innovation, and the takeaway message I'd like to leave y'all with is if you find companies that are doing that and pushing that real change, support them, help them connect, because that's how you can help contribute to that and to a better world, in my opinion, without really having to do too much. And there is one last slide, but if anyone wants to connect after this, there's our info. So thank you so much.
So this, for me, what feels so significant about this, it feels like a Star Trek replicator. Feels like, you can build anything you want, even, correct me if I'm wrong, even like chips, semiconductors.
Yes. Yeah. Our technology for semiconductor production is doing well. What we're pushing for is below 2 nanometer chip production, which, if you know what that means, when most of your phones, computers run off something that's between 7 and 13 nanometers, the smaller you go, the more data you can process, the faster of a chip you make. And for things like AI, they're currently bottlenecking a lot of semiconductor production. We need that to catch up.
And it'd be very easy for those of us who are maybe not in the space to think, oh, this is like a tech bro thing, or this is like only for the specialized electronics thing. But you have Disney making their costumes using your product,
and it's a way to take a lot of traditionally 1 or 2 dimensional, very simple production processes and literally add new dimensions to that. So if we're talking semiconductors, what if you build up? What if you have a 3-dimensional semiconductor? If we're talking agriculture, we have companies using to make, because nature's shapes aren't always the most manufacturable, we're making super efficient growth structures that are counteracting gravity to make more nutrient-rich, faster going clients in agriculture. Right? We're looking at maintenance items. And without playing in a supply chain, on-site, on demand, the more steps you do in one, the less of a footprint you have, the less energy you consume. But when you don't play into the shipping, the distribution, or everything else, it's substantially more efficient. If we're talking sustainability, we've had folks that take anywhere from landfill trash, grind it down, which when you do that, there's not many uses of it. It's 40% plastic, but 60% fiber. So there's clothes, there's nylons and everything we use. But if you have a method that can not only cut fibers but mold plastic and do both at the same time, we've been able to turn it into products that are comparable to plywood. You can take ocean plastics that have already been processed, and sure, you can buy plastic for $22 a kilo, or you can buy an ocean plastic for $7 a kilo. And if your advanced manufacturing platform's advanced enough, you can use something with the same chemical structure for a fraction of the cost, and it'll be stronger, more heat resistant, and again, cost you less, and you can say you have an impact. It makes sustainability profitable, and that's how you get these corporates that have all these lofty goals that you say, oh, we'll do this years from now. They hope you forget when we get there because they didn't reach it, because it doesn't automatically give them ROI. Something like this does. And that's why we're seeing so much interest and mass adoption for it already.
Well, there's that side of it that we can make manufacturing and even, I would say, distribution sustainable, but it almost eliminates the need for distribution because you can manufacture on site. But I think and it may not be like a generation 1 or 2 in terms of affordability, but if you think, we've talked this weekend with Florian for Threefold and Our World about being able to leapfrog some of the need to develop infrastructure in some of the developing parts of the world, in Africa and Latin America, where, we've really held people back. But instead of like installing phone lines, we would, just jump to cell towers. Imagine places in the world that haven't had the abundance of resources, had this and had the ability to manufacture whatever they wanted. For me, this is financial and other forms of economic empowerment are another kind of hidden benefit that can come out of this.
Yeah.
So a question go ahead.
Yeah, you connect the world. And look how we've been seeing software development come out of Africa, which I think was unexpected, say 20 years ago to a lot of people. But you give a community that has the time to really focus in, educate themselves. We're seeing innovation out there because you can get your friends together, you can hackathon overnight, you can show a software product. And if we give that same community their own manufacturing power, sure, it's providing for them during the day, but maybe it's not operating during the night, though you give them, the folks in that community, the ability to innovate for themselves and contribute to that global populace. And if more of the world adapts something like that factory in a box, whatever design they make out there can instantly be distributed to the world without playing into the whole supply chain. And I think you mentioned costs a little bit. We've actually been able to undercut mass production Chinese production costs. Like one of the things we did to qualify ourselves for some certain government programs was we found a self-healing drone for the DoD. We 3D printed carbon fiber. We picked up place in semiconductors. We took what would be a 1 foot by 1 foot flat circuit board and turned into a less than 3 inch by 3 inch cube by making one of the first 3-dimensional circuit boards by going vertically and diagonal with the tracings. But at the end of the day, we did 4 of them in less than 30 hours in shapes and structures that current manufacturing cannot do. And we did so at a rate that was about 30% less than Chinese production costs, simply because we're talking about hundreds of millions of dollars of machinery oftentimes on these production lines, and the cost of goods sold is substantially less. You don't need to factor in all that machine cost, power costs, affordable labor, and then not to mention the distribution, the middlemen when you buy from Amazon, the warehousing costs, the inventory, excess inventory costs, the waste, etc. On demand, you start to get pretty competitive.
Well, notwithstanding also that in order to make the kind of large manufacturing profitable, you have to mass produce.
Yep.
Whereas here you can manufacture one thing at a time as affordably as otherwise. So that for me is wildly exciting. Last, before we let you go,
Sure.
What do you need? How can we help?
Yeah, well, like I said, it's early and late in a lot of ways, where we've been working on this since 2017 officially, 2015 unofficially, and we've been stuck and we haven't been able to really talk about it, which around UNGA is the first time I've been able to give the full story on, hey, we're doing the semiconductors, we're doing the all-in-one production, not just the initial public perception that we were trying to give of, again, 3D printing, then build people up to the concept of an all-in-one. So it's been, first of all, it's been a lot of use cases in unique sectors. So we've been trying to have representatives using this technology, representing anything from cosmetics to fashion to agriculture to aerospace, automobiles, general warehousing manufacturing, etc. And we're still looking for folks that might want 1 or 2 and not the 20s, the hundreds that we're getting at the moment. And in addition to that, it's capital. 80% of our supply chain is in-house, since we're using our own factories in a box to make our own factories in a box. They're dependent on shapes you can't make in any other way, and we built a completely proprietary production line to do it. But it means if we want to produce more, bigger warehouses, more staff, more everything else, and if we want to meet those LOIs in a realistic timeline, it's unfortunately capital partners too, and finding ones that can align with that vision and not say, hey, I know you have 3 acquisition offers on your table, take it as long as I want a return. We're looking to have a global impact, and we see this as technology can realistically do so.
and not insignificantly can have massive impact, but can be a good investment for even an investor who's not actually caring about impact. Its returns are not insignificant. And for me, I know it's not technically, or you can't call it 3D printing, but for me, a 3D printer that can print 3D printers, hold on, like that's pretty massive. So thank you so much for being here. There's any more is out. I hope the investors in the room, particularly those focused on infrastructure, get the chance to talk with you. Thank you again.
Thank you.